In the last video, we discussed about discrete random variable and discrete probability distribution, and we did one discrete probability distribution, that is the binomial distribution. Okay, so for example, what was the discrete random variable? The random variable x is discrete if it can take only countably many values of x. Okay, if there are only countably many values, for example 0, 1, 2, and then so on. Okay, for example, let us take an example. A family has 3 children. Okay, and then let x denotes the number of boys. So what are the possible values of x? So x can be either 0 boys, meaning all girls, right? 1 boys or 2 girls, that means 2 boys, 1 girl, or 3 boys and 0 girls. So these are the values of x can take. So it is taking finitely many here, but you can count, right? 0, 1, 2, 3, 4, because the number of boys cannot be 1.1, 1.2, 1.3, like it cannot be decimal, right? So x can be counted, meaning the number of boys can be counted. So it is the discrete random variable. X is the discrete random variable, right? And also we made a probability distribution. We made a table like x, and then we wrote px, right? So x is the random variable and px is the probability of that random variable. How did we create this table? Was we wrote the values of x, 0, 1, 2, and then 3. Do you remember what was the probability of 0 boys in a family of 3 children? So to find out that probability distribution, we need to find out the sample space first, right? So all of them can be boy, boy, and boy. Boys, boy, 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 and girl, right? Boy, girl, boy. Girl, boy, boy, right? And then what else is girl, girl, boy, right? Girl, boy, girl, and then boy, girl, girl, and then girl, girl, girl. These are the possibilities, right? The first child can be boy, second can be boy, third can be boy. The first can be boy, second can be boy, or third can be girl, and so on. Okay, in this case, what is the probability of x is the number of boys, right? What is the probability of 0 boy? How many have 0 boys? This sequence, that pattern, or that group has 0 boy, right? Only 1 out of 8, because 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possibilities in total, and only 1 has a 0 boy, that is all girls. So what is the probability? Is 1 over 8. Similarly, 1 boy. How many have 1 boy? That is this one, and that one has 1 boy. So that will be 3 out of 8. And then 2 boy is also 3 out of 8, and 3 boys is 1 out of 8. That's what we did, and this is called discrete probability distribution, because this distribution has the value of random variable, and we are able to write the probability of each of these values. Okay, this is an example of discrete probability distribution. And also we draw a histogram for this, right? How did we draw the histogram? We wrote the values of x along x-axis and then px along y-axis, right? And what we did is we wrote the value of 0 boys, 1 boy, 2 boys, and then 3 boys here. And then we draw, let's say this is 1/8, this is 2/8, and this is 3/8, right? So 1/8. So how many have 0 has the probability 1/8, right? You do that. And then 1 has probability 3/8, right? You do that. And then 2 has probability 3/8 as well, that is 3/8, and the 3 has probability 1/8. That's how we drew the polygons, right? Or the histogram, you say. This is the histogram. All right, now you see that if you draw a polygon from the middle of these basically these histogram, then you see the polygon. Okay, or if you try to make a smooth curve there, right? You did that in the chapter 2. If you try to make a smooth curve like this, you see that this curve is bell shaped, right? This is a bell shaped curve, or this distribution is bell shaped, or you can think of symmetric distribution. Okay, this distribution is almost symmetric distribution. All right. So this is an example of discrete random variable and discrete probability distribution. Okay, now let us take another example. That is, let us suppose that say to enroll for a study, the weight needs to be between 120 and 150 pounds. Okay, to enroll in any study, the weight should be between 120 and 150 pounds. Okay, now here, so let X denotes the weight. Okay, so weight can be anything between 120 and 150 pounds. So can you list all values of X? So the smallest one can be 120, and it can be 120, it could be 120.1, 120.01, 02, and so many, all those things. So you cannot list all these values between 120 and 150, because that X is the weight, can be any number. It can be decimal, it can be many decimals after 120.1 or 120.01, 0001. So it is hard to list, or you cannot list. Okay, in this case you cannot make X and PX here. Okay, you cannot make this type of chart. So in this example, the X, random variable X, is continuous. So we cannot list them because this is continuous random variable. Continuous random variable. Okay, so we cannot make a table to list the values of X and the probabilities here. Okay, so this type of variable is called continuous random variable, where the random variable X can take any number between two numbers, not only the integer, or not only the countably many, because you cannot count how many are there. It is infinitely many, also uncountable. We call it uncountable because it can take any values there. Okay, it is hard to count, because for example, if you say how many numbers are between 0 and 1, they are uncountable, right? It can be 0, 0.1, 0.001, 0001, and so many there, and then 0.2, 0.002, 0002, 21, 22, all those are possible. It's similar to this. Since it says between 120 and 150, there are infinite or uncountably many values. So you cannot count all the numbers between 120 and 150. So in this case, the random variable X is called continuous random variable. Okay, so unlike the discrete random variable, you cannot list all these values because there are uncountably many, and you cannot make a distribution like this. You cannot make a table like this. So this is a continuous random variable, and we will do slightly differently to find out the probabilities under the continuous random variable. Okay, so in the discrete random variable, I gave you one discrete probability distribution, that was the binomial distribution. Okay, but a continuous random variable also, there are many continuous distributions. Okay, continuous probability distribution. So one of the distribution we discussed in this class is normal distribution. Okay, so the chapter 6 is about normal distribution. Okay, so on this chapter we will talk about the normal distribution, and we will try to find out the probability under the normally distributed population. Okay, so as I just mentioned, the continuous random variable is the variable that can take any values, that is uncountably many values. Okay, so that random variable is called continuous random variable, and the distribution, the probability distribution of the continuous random variable is called continuous probability distribution. And there are many types of continuous probability distribution. One of them is normal distribution. Okay, so if a random variable has a probability distribution whose graph is continuous, if the graph of the probability distribution is continuous, bell-shaped and symmetric, then it is called normal distribution. Okay, so what do you mean by bell-shaped and symmetric? So it is continuous, right? There is no break, and then bell-shaped, and then symmetric. So symmetric means if you cut it in the middle and if you fold it, those two sides overlap. Okay, then it is called the normal distribution. So you don't have to worry about the equation of the normal distribution, but if you want to plot the graph, this is what the equation look like. Okay, if you plot this equation, 1 over sigma is a number, that is the standard deviation. Okay, 2 pi is the pi, 22 over 7, and e is a number whose value is almost 2.71. Your calculator has e, and then minus x minus mu is a mean of the distribution, and then square over 2 sigma square. This is the equation. Okay, but no worries about the equation. We don't do anything in this class about the equation here. Okay, the shape and the position of a normal distribution curve depends on two parameters. The mean, we denote that by mu, and the standard deviation, we denote that by sigma. Okay, each normally distributed variable has its own normal distribution curve, which depends on the values of mean and the standard deviation. Look at these two values. Okay, these two graph here. On the first one, both of them have the same mean, but on the blue curve, it has a mean is 0, sigma is 2. On the brown curve, there is mean is 0, sigma is 1. You see that? When the sigma or when the standard deviation is bigger, that means the variable is more scattered, right? The variable is more scattered. That means the curve will be more flat. Okay, but we have the same mean here. And in this case, in the second case, we have the same standard deviation. See, sigma is 2 in both cases, right? But mean is different. If the mean is different, then you see the distribution in the different location. Okay, but if the mean is same and the standard deviation is different, then the peakness or the flatness of the curve are different. Okay, but both of these are the normal distribution. So this is also normal distribution because it is continuous, bell-shaped and symmetric. These are also normal distribution, continuous, bell-shaped and symmetric. But depending on the values of sigmas and mu's, see, whenever you change the sigma or mu, then you see the different curve in the different locations. All right. Okay. So how do we identify, how do we recognize whether a distribution is normal distribution or non-normal distribution? Okay, let us see some of the properties of the normal distribution. So the one property is the normal distribution is bell-shaped. You guys know that already, bell-shaped or symmetric. See, it is the bell-shaped, it is normal distribution. The mean, median and mode are equal. See, they are all located in the middle. The mean is in the middle. The median is the highest frequency here, right? I mean, the mode is the highest frequency. So this is the mode. And also median means on the both side of this point, there are equal number of x values or the random variables. Okay. And the normal distribution is unimodal, meaning it has only one peak point. That is the unimodal. The curve is symmetrical about the mean, which is equivalent to saying that its shape is the same on both sides of the vertical line passing through the center. See, if you cut it in the middle and then if you fold it, they will overlap. So this is the normal distribution property. The curve is continuous because it is the distribution of the continuous random variable. Okay, there are no gaps or hole in the graph, so it is continuous graph. For each value of x, there is corresponding value of y. So these are the x values. For whatever value of x you pick, there is a value of y there. Okay, that means there is no gap or holes. The curve never touches x-axis. You see that it is getting very, very close to x-axis, but it is not touching x-axis. So if you expand this in either direction, it should not touch x-axis, but it will very close to x-axis. So in other words, you can say that it is asymptotic to the x-axis. Okay, x-axis is the asymptote to the curve. Okay, so no matter how far in either direction the curve extends, it never meets the x-axis, but it gets increasingly close, meaning that this is the asymptote. X-axis is the asymptote to the curve. So these are the properties of the normal distribution. These two curves are not normal. This is left skewed or the left tailed. Okay, this is the right tail or the right skewed. Okay, so this is the normal distribution. So this is basically the symmetric, continuous, and then bell-shaped curve. So this is the normal distribution. All right, so the next thing we do is we will find out the area under the normal distribution. Okay, so there is a calculator to do that, so we will discuss about the area under normal distribution.